In Yellowstone National Park, geologists say one of the park's famous geyser basins now has a new hot spring.
It's one of the largest supervolcanoes in the country, and recent work out of the University of New Mexico led to a breakthrough discovery that could help geoscientists better predict.
Massive cracks slicing across the ground of Yellowstone Park sent shockwaves of concern through scientists and authorities, leading the US Geological Survey to issue a rare red alert. Few places in the world command as much attention as Yellowstone when even subtle shifts occur beneath its surface. This isn't just another patch of wilderness. It is the crown of a vast and restless volcanic system that has both shaped the landscape and haunted the imagination of experts for decades. When word spread that large fractures had opened in the park's terrain, speculation immediately surged. Cracks of this magnitude do not appear in isolation. They are physical scars that tell the story of extraordinary geological pressure building below. Before we start, smash the like and subscribe buttons for more updates. The discovery of these fissures is not a trivial detail to be brushed aside. Yellowstone rests atop one of the most powerful volcanic hotspots on Earth, a supervolcano that has erupted with unimaginable force multiple times in Earth's history. Each past eruption dramatically altered the landscape, blasting ash across continents and influencing climates for centuries. When cracks begin to spiderweb across the surface, it is often the land's way of releasing stress, of adjusting to forces deep beneath. What unsettles researchers is not just their sudden appearance, but their size, distribution, and association with seismic tremors that have rattled the region in recent weeks. The USGS Red Alert signals the highest level of concern in their monitoring system. Such an alert is reserved only for extraordinary circumstances when data points converge to suggest significant unrest in the volcanic system. For Yellowstone, it's a sobering reminder of the dynamic nature of the terrain. The ground beneath the park is alive, breathing with heat and pressure, pulsing with molten rock that shifts and churns far below. These cracks are now viewed as potential channels where energy has sought release. Their presence is not merely cosmetic. They change the way geologists interpret the stability of the region. The park itself provides plenty of visible reminders of its fiery underworld. Geysers erupt like clockwork, boiling hot springs shimmer with unnatural colors, and steam vents hiss endlessly, hinting at the immense thermal engine below. Yet cracks in the earth bring the subterranean drama to the surface in a more unsettling fashion. A geyser can dazzle tourists, but a sudden fracture stretching across a valley speaks of tectonic shifts and potential instability. The USGS's decision to issue a red alert underscores that these cracks are not considered ordinary. They suggest a reorganization of stresses within the supervolcano's caldera, a process that carries both scientific intrigue and serious implications. At the heart of the concern is magma movement. Yellowstone's underground chamber is a massive reservoir of molten and semi-molten rock. The creation of large cracks often points toward pressure forcing its way upward, straining the overlying crust. Such activity can sometimes precede eruptions, though not always catastrophic ones. Still, the ambiguity is what keeps scientists on edge. The Earth rarely announces its plans with clarity. Instead, it leaves fragments of evidence, fractures, tremors, gas releases, that must be pieced together. In this case, the evidence points to heightened volcanic unrest, and the cracks are physical manifestations of that invisible drama. The appearance of these fissures also alters the landscape in tangible ways. Trails once considered safe may now be compromised, while sections of forest or grassland could shift unexpectedly if the ground continues to move. Entire ecosystems feel the tremor of such changes. Animals, sensitive to vibrations and subtle chemical shifts in the soil, may react before humans fully register the danger. Herds of bison have been observed moving to new pastures, elk herds changing their routes, and birds abandoning nesting areas. Whether or not these behaviors are directly linked to the cracks, they add to the atmosphere of unease. From a scientific standpoint, the red alert allows for increased surveillance. Instruments planted throughout Yellowstone are now feeding more frequent and detailed streams of data back to monitoring stations. Seismographs trace the tiniest tremors. GPS sensors measure ground deformation down to millimeters. And gas detectors sniff for changes in sulfur dioxide or carbon dioxide levels. These technologies paint a clearer picture of what is happening beneath the surface. When cracks appear in multiple locations, Scientists often cross-check whether they align with faults, hydrothermal systems, or magma pathways. In Yellowstone, the correlation is disquieting. The cracks seem to mirror known lines of weakness across the caldera. For local communities, the news is difficult to process. The park is not just a natural wonder, but also a cornerstone of tourism and livelihood in the region. Towns around Yellowstone rely on the steady influx of visitors eager to witness its geysers and wildlife. A red alert, however, casts a long shadow over the future. Although authorities stress that it does not necessarily mean an eruption is imminent, the very phrase red alert carries heavy weight. Businesses must weigh safety against economics. Residents must reconcile their proximity to a restless giant, and visitors are left with a mixture of awe and apprehension. Geologists are quick to clarify that Yellowstone has issued warnings before without leading to cataclysmic eruptions. The volcanic system is complex, and not every sign of unrest culminates in disaster. However, the scale of the newly discovered cracks makes the situation different. They are larger, more widespread, and appear to be linked with measurable ground uplift. Sections of the park have risen several inches in a short span of time, evidence that the crust is swelling under pressure. This combination, ground deformation, fractures, seismic activity, and gas emissions, creates the precise recipe that demands heightened alert levels. The cracks themselves tell silent stories. Some are narrow but extend for hundreds of feet, cutting across ridges and meadows with surgical precision. Others gape wider, exposing raw soil where roots dangle helplessly. In certain areas, steam hisses from the fractures, suggesting a link to the hydrothermal system. Each crack is a wound in the Earth's surface, and together they form a pattern that hints at deeper turmoil. These are not random accidents, but consequences of massive geologic forces. Their alignment often reveals the direction of stress, the points where the crust has reached its breaking point. Looking deeper into Yellowstone's geologic record, one sees a pattern of cycles. Eruptions, both minor and major, have punctuated its history for millions of years. Between these explosive events, the land shifts, deforms, and heals itself, leaving behind clues for modern science. The cracks are the latest chapter in this unfolding story. To scientists, they represent a chance to study the processes that precede volcanic events in real time. Each instrument reading, each mapped fracture adds to humanity's growing library of knowledge about how supervolcanoes behave. This knowledge is critical, not just for Yellowstone, but for understanding volcanic hazards across the globe. The atmosphere in the park has become charged with a mixture of wonder and anxiety. Tourists who expected a serene encounter with nature now find themselves walking near landscapes split open by deep fissures. Rangers patrol with renewed vigilance, guiding visitors away from unstable areas and monitoring conditions daily. Even the most experienced staff acknowledge that the ground beneath their feet feels more unpredictable than usual. For them, the red alert is not an abstraction, but a constant reminder of the potential volatility of their surroundings. Media attention has amplified the sense of urgency, with images of gaping cracks circulating worldwide. While such coverage can lean towards sensationalism, it reflects a very real reality. Yellowstone's activity is never far from the global spotlight. This park, after all, is not just a U.S. treasure, but a planetary hotspot of geological significance. Scientists from across the world monitor it closely, eager to understand the signals it sends. The cracks and the red alert will no doubt lead to international collaborations, fresh studies, and new theories about supervolcano dynamics. The situation also raises questions about preparedness. How ready is the nation to respond if Yellowstone's unrest were to escalate? The cracks may not signal an impending catastrophe, but they remind everyone of the stakes. Emergency protocols, evacuation routes, and communication strategies are all being revisited. The red alert acts as a wake-up call to governments, agencies, and citizens alike. It is not simply about what is happening in Yellowstone today, but about the broader challenge of living alongside forces that dwarf human control. The sheer scale of Yellowstone's volcanic system makes every development significant. Unlike smaller volcanoes, which may erupt more frequently but with localized impacts, Yellowstone's potential reaches across continents. The cracks serve as visible proof that the system remains active, evolving, and capable of surprising even the most seasoned experts. That element of unpredictability fuels both fear and fascination. To walk across a meadow that has suddenly split apart is to confront the raw power of nature, unmediated and undeniable, At the same time, the cracks are a reminder of Earth's resilience and dynamism. They illustrate how the planet continually reshapes itself, breaking and rebuilding in endless cycles. For all the concern they cause, they are also a testament to geological processes that have sculpted landscapes for billions of years. Yellowstone's cracks are not just warnings, they are lessons carved into the soil, lessons about change, pressure, and release. They invite reflection on humanity's place in a world governed by forces far older and stronger than civilization itself. As the red alert continues, scientists remain at the forefront, piecing together the puzzle with urgency and care. Each new reading could tip the balance between reassurance and alarm. The cracks are not passive features. They are dynamic, evolving as the days pass. Some widen, others deepen, and new ones may appear without warning. This constant evolution keeps the research teams on edge, never fully certain of what tomorrow will bring. The challenge lies in interpreting these changes quickly enough to provide guidance while acknowledging that nature often resists simple explanations. The cracks in Yellowstone Park stand as stark symbols of the supervolcano's restless heart. They are reminders that beneath the forests, rivers, and geysers lies a colossal force that has shaped North America's landscape countless times. The USGS Red Alert is more than a bureaucratic warning. It is a recognition of the magnitude of these changes. It draws attention to the urgency of studying, preparing, and respecting the immense geological forces at play. While the future remains uncertain, the cracks etched into Yellowstone's soil make one fact undeniable. This land is alive, restless, and still writing its fiery story beneath our feet. The cracks that now mar the landscape of Yellowstone Park are more than just scars on the surface. They are openings into the restless life of the earth below. Each one is a physical representation of pressure that has accumulated, stress that has finally forced its way to daylight. As the USGS Red Alert remains active, attention has shifted to the finer details of what these fissures mean, not only in terms of immediate safety, but also in the context of Yellowstone's geological narrative stretching back millions of years. Yellowstone is not a static monument. It is a living, shifting entity, shaped by forces that operate on scales most of us rarely contemplate. Its vast caldera, formed by previous super eruptions, stretches for miles and represents one of the most impressive depressions on Earth's surface. When fresh cracks appear within this already dramatic structure, they raise the question of how the caldera is behaving today compared to its long and violent past. Geological records show that between the great eruptions, the land does not rest silently. Instead, it warps, uplifts, subsides, and fractures, each motion contributing to an ongoing cycle of stress and release. The current cracks fall neatly into this cycle, but their suddenness and scale elevate their importance. What sets these fissures apart is not only their size, but their context. Yellowstone has long been riddled with small surface fractures, often created by the shifting of hydrothermal systems or localized seismic events. However, the cracks discovered this time appear to align with zones where magma is known to intrude. Such an association is unsettling because it implies more than surface instability. It suggests that the molten reservoir below may be reorganizing itself. The red alert acknowledges that the cracks are symptomatic of deeper unrest, not just shallow shifts. For scientists, this is an opportunity to watch geological forces unfold in real time, but it also brings the sobering reminder of the risks tied to such activity. The terrain around Yellowstone has always been unstable. Visitors who wander through the park notice signs of this instability every day, from the trembling of ground near geyser basins to the faint smell of sulfur rising from steaming vents. But fissures cutting across roads, trails, and forests represent a different category of danger. These cracks can swallow sections of infrastructure, destabilize hillsides, and reroute streams. A creek once flowing through a meadow may now vanish into a jagged fracture, its course forever altered. These changes ripple outward, impacting wildlife that depends on predictable landscapes. Fish populations can decline if water temperatures rise suddenly from geothermal influence, while plant communities may die off if the soil around a crack heats beyond their tolerance. The land is not only moving, it is reshaping the living systems that call it home. Scientists observing these events often describe the cracks as clues in an unfolding mystery. Every tremor, every puff of steam, every shifting block of ground feeds into the puzzle of Yellowstone's subterranean activity. Sophisticated models of the caldera rely on such data points, and these new cracks provide fresh evidence to refine predictions. While it is nearly impossible to say with certainty whether an eruption will follow, the details gathered from the fissures can help forecast the type of activity most likely to occur, whether it is an increase in hydrothermal explosions, smaller, localized eruptions of lava, or simply a prolonged period of deformation with no major release. In all scenarios, the cracks remind humanity that Yellowstone is not dormant. The global interest in Yellowstone's latest cracks reflects more than curiosity. It underscores how interconnected the world has become in the face of natural hazards. Yellowstone's potential to influence global climate through a major eruption is well documented. While the cracks alone are not predictors of such an event, they ignite a chain of discussions among scientists, governments, and even ordinary citizens who live thousands of miles away. The red alert is not simply a regional issue, it reverberates across the globe. International research stations are now poring over satellite imagery, tracking thermal anomalies, and coordinating with USGS teams to compare data. The fissures in Yellowstone become a shared point of study, a reminder that Earth's most powerful natural forces do not recognize borders. There is also a psychological dimension to the appearance of these cracks. For many, Yellowstone has always carried an air of mystery, a place where the raw power of the Earth simmers close to the surface. The park's geysers, boiling pools, and sulfur-scented air already give visitors a sense that they are standing atop something otherworldly. Now, with vast cracks splitting the land, that uneasy feeling has intensified. The red alert crystallizes those fears into official recognition. The knowledge that experts see sufficient cause for concern amplifies the unease, turning natural wonder into anxious observation. People who once viewed Yellowstone as a vacation destination now see it as a reminder of nature's fragility and fury. At the same time, the cracks have inspired a surge of scientific collaboration. Researchers are seizing this chance to study fault mechanics, magma movement, and crustal deformation in a way that textbooks alone cannot convey. Instruments positioned near the fissures measure changes in temperature, gas composition, and microseismic activity. Scientists hope to catch signals that might reveal how pressure migrates through the Earth's crust. Every sample of gas escaping from a crack, every reading of the ground's subtle rise or fall, contributes to the body of knowledge that could one day improve volcanic forecasting, not only for Yellowstone, but for other active systems worldwide. This scientific urgency reflects the dual nature of Yellowstone's cracks. They are threats, but they are also teachers. From them, humanity can learn about processes that remain largely hidden from view. For example, when a crack begins to vent gases rich in carbon dioxide or sulfur dioxide, it suggests that pathways between the magma chamber and the surface are opening. The ratio of these gases can indicate whether magma is nearing the surface or whether the gases are escaping from shallower hydrothermal systems. These details help refine our understanding of what is happening beneath Yellowstone's crust. The presence of large cracks also changes the way emergency planners view the region. A red alert forces local and national agencies to re-examine evacuation strategies, communication networks, and contingency supplies. The fissures have made clear that the ground itself cannot be assumed stable, even in places long used by tourists or rangers. Roads may buckle, power lines may snap, and communication towers may be compromised if the land continues to deform. Planning for such scenarios requires rapid coordination between geologists, engineers, and policymakers. The cracks, though unsettling, serve as catalysts for improving resilience. Beyond the immediate region, the rest of the world watches closely, because Yellowstone is emblematic of a broader challenge: humanity's relationship with supervolcanoes. There are only a handful of such systems across the planet, and each one carries the potential to alter global climates. The cracks in Yellowstone provide a window into the early stages of volcanic unrest at this scale. If scientists can decipher what these fissures mean, they may gain tools to better interpret signals from other supervolcanoes, whether in Indonesia, New Zealand, or South America. Yellowstone's turmoil thus becomes a global case study in geological vigilance. Cultural perspectives also come into play. Indigenous communities with deep ties to the Yellowstone region have long viewed the land as sacred, alive with forces beyond human comprehension. For them, The cracks may not be mere scientific anomalies, but spiritual signs. The red alert amplifies both the scientific and cultural interpretations of these events, reminding us that human understanding of Earth's processes comes in many forms. The meeting of scientific precision and cultural wisdom enriches the narrative, offering layers of meaning that transcend simple explanations. The cracks themselves continue to evolve. Reports describe some widening steadily, while others appear to stabilize. This unpredictability mirrors the volatile nature of Yellowstone's entire system. Even as scientists monitor them closely, they know that the next shift could be entirely unexpected. New fissures could open in different areas, or the current ones could suddenly collapse, creating dangerous sinkholes. The unpredictability fuels both caution and fascination, drawing more eyes and instruments to Yellowstone's surface than ever before. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Yellowstone's massive cracks and possible eruption risks? We want to hear from you. Thank you for watching and see you next time.